So we'll make sure we're recording the meeting. Give people a few minutes to arrive. So someone has asked, when will the next midterm be? That's a very good question. So the next midterm is October 22nd. It's a Friday. And it'll start at 9 a.m. You'll have a 24-hour window from 9 Friday to 9 on Saturday. It's a 3-hour test. And it's 25 questions. So homework for chapters 5, 6, 7, and 8 will also, the last date you can go to is October 22nd at 9 a.m. People in the previous set were very interested in having the chat box or the check box come back. And so we went into Moodle yesterday and found out how to put that checkbox into all the questions. So if you've already started the chapters, it won't be there. But if you have to redo it, that checkbox will appear. So hopefully that will help some people save a little time. So you definitely want to today we're going to look at chapter 8. And you're going to watch the chapter 7 video on Moodle. Some of you may have done that as I brought it to your attention yesterday. But if not, sometime this week you want to watch that. So any other questions you can think of asking? Other assignment? Yes, chapter 5 is a big chapter, and it has part A, B, and C, and you have to do all 3 of them. Any other questions you feel you would like to ask before we leap joyfully into chapter 8?
There is a due date from the homework from chapter 7 and 8 or not?
Will all be due on October 22nd.
Thank you.
Okay. Okay, so I'm not seeing any other questions. I'm assuming everybody who's going to be here is here now, or they're planning on watching this video later. Let's take a look at what we're doing in chapter 8. So what we're dealing with here is the concept of simple interest. The reason they call it simple interest is it only involves one calculation. And simple interest is chapter 7 and 8. Compound interest is the entire rest of the textbook, chapters 9 to 16, all deal with compound interest. And the difference between simple interest and compound interest is when you're dealing with compound interest, you're dealing with situations where you pay interest on the interest. And let me try and explain what I mean by such a strange statement. Let's say we're compounding monthly. And so we start here, and let's say you've put money in the bank. For the first month, the bank pays you interest at the end of that month on the money that you put in. But The next month, they pay you interest on the money you've put in plus your interest. So the interest on the second month will be slightly higher than the interest they paid on the first month, because now they're paying you interest on the interest. For the next month, it'll be slightly higher again, because they're paying you interest on the original sum of money on the first month's interest, and now they're paying interest on the second month's interest. That's what they mean by the interest compounds. You pay interest on the interest. And so we have, theoretically, there are many different calculations going on here. But in fact, we still only do one calculation. It's just a more complicated calculation than the simple interest calculation. The simple interest calculation is we just do one calculation, and this is the amount we're paying back, end of story. We're not compounding the interest. And so in this chapter, chapter 7 and 8, that's all we're doing. Whereas in chapter 9 to 16, we're dealing with situations dealing with compound interest. So, but we can ignore that for now. Let's just get rid of that. And look at the concept of simple interest. The most simple sort of calculation they start with is the fact that the interest amount equals the principal times the rate times the time. So P is the principal, or the present value, the little r here is the interest rate, and it'll always be an annual or yearly rate. And the little t is the time. And it'll be either in days, months, or years. And we'll always have to translate it into annual. So if it's days, we'll divide it by 365 to turn it into a fractional part of a year. If it's months, we'll divide it by 12 to turn it into a fractional part of a year, so it matches the interest rate. And if it's years, we'll divide by 1, which we don't really do. And the big letter I here is the interest amount. That's the amount of money that has to be added to the principal to pay back. So once they've given you this equation, then they're going to want to substitute this into this equation. We're going to have S, which is the sum of the principal plus the interest. And then they're going to substitute what we know this belongs to, or this means, back into here. So S equals P plus PRT. And then they're going to factor out the P. So you're going to get S equals P 1 plus RT. And it's this equation we're going to be using today. And they're going to use it both to solve for the sum, the future value, and they're going to turn it inside out to solve for the principal. They're going to go principal equals S divided by 1 plus RT. So today, we're going to be using this equation to move money forward. And we're going to be using this equation to move money backward. And that's basically what we're doing. We're moving money forward in time. And when you move money forward, it gains interest. And we're going to be moving money backward in time, and it loses interest. So we're going to spend a lot of time working with these two equations. Once in a while, we'll have to use this one. And with this equation, they'll make us solve for the letter R here. They'll get R equals the interest amount over the principal times the time. Because in some situations, they want us to figure out what rate of return people got on their investment. So rate of return or rate of interest, same thing. So armed with those four formulas, let's take a look at what we're doing. This chapter is called Simple Interest Applications, and the specific applications we're going to look at are something called promissory notes, something called treasury bills, and another aspect or application called demand loans. So let's take a look at what we're doing here. So let's talk about what a promissory note is before we jump into it. This is a situation where one person or company has loaned money to another person or company. And the promissory note is a piece of paper. And on this piece of paper, there has to be four important pieces of information. One of them is the amount of money that was borrowed. And so in the standard situation, we have to figure out the amount that has to be paid back. I say the standard situation because sometimes they switch it up and they give us the amount that's paid back and we have to figure out the amount that was borrowed. But the basic idea is that we would know the amount that was borrowed and we'd figure out the amount that has to be paid back. It also has to have the date the money was borrowed. And again, quite often, the standard situation is that we know the date the money was borrowed, and we have to figure out the date the money has to be paid back. But the piece of paper, the promissory note, if we could actually see it, it would include the date the money was borrowed. the rate of interest has to be on there. And that'll always be an annual rate. And the fourth is the time period. That is, how long is the money borrowed for? So a promissory note has to contain those four pieces of information. And so we'll start with sort of a standard promissory note where we've got to figure out how much is paid back, what date it's going to be paid back on. So we have a 4-month promissory note for $1,600. It's dated June 30th, and it bears interest at 6.5%. So this is the 4 pieces of information that a promissory note must contain. And so let's take a look. I will draw this thing that I refer to as a timeline. And we know this thing is a 4-month note. So 1, 2, 3, 4. And it was dated June 30th. So that's the issue date. So we know this is June 30th. And it bears interest at 6.5%. And the amount of money that was borrowed is $1,600. Now, when we go forward, we always go forward either from the end of the month to 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 the end of the month. And this is June 30th. So this is the end of June. So we're going to go, when we count months, we're going to go to July 31st, August 31st, September 30th. So June, July, August, September, October 31st. This note is due on the last day of October. If we'd been June 15th or somewhere in the middle of the month, we'd have gone July 15th, August 15th, September 15th, October 15th. We'd have always stayed on the date that we started on. It's only on the end of the month you're going to go end of month, end of month, end of month, end of month. So here we are on October 31st. And the first thing we need to do is figure out how many days this is. And we have 2 ways of doing this. We can either use what's called the days between dates function on the BA2 plus, or we can use Excel. And I'm going to do both today so you can see how they work. Let's do the days between dates on the BA2 plus first. So I'll write down what I'm going to put into the calculator, and then we'll actually go over and look at the calculator and do it. The way it works on your calculator is you're going to go second, and then you're going to go date. And the date, in order to find it, it's the second function of the number 1 key. So if you can find that on your calculator, go second, date. And then what you should be looking at is DT1. And that stands for date 1. And the format here is it's always going to be the month. Then you're going to put in a decimal point. Then you're going to put in the day. And then you're going to put in the year. No decimal point between day and year. So we have to look over here, June. So we've got to figure out that's the 6th month and decimal point, and the day is 30. And notice they haven't given us any year. And so now we have to wonder whether we're in a leap year or not. But notice if we go from June to October, we're not passing over the end of February. So it doesn't matter whether this is a leap year or not. So I'm going to just go from June, I'll use this year, 2021, to October 2021. Because although they didn't put a date in the question, we need a date to keep the calculator happy. And we can only put in the last 2 digits. So what you're putting into your calculator is 6.3021. And then you're going to go enter and hit the down arrow. So enter and down. And now you should be looking at DT2, which is the second date. So we're October. So this was 6, 7, 8, 9. October is the 10th month. Decimal point 31. And we're still in the year 2021. And go enter and down. So 10.3121, enter down. Now you'll be looking at DBD, and it doesn't matter what there is in there, you're going to hit compute, and then it'll actually tell you. And I noticed someone has followed along correctly, and they've got the right number of days coming up there. 123. So now that we've seen how I'm going to plug it into the calculator, let's go and actually find the calculator. So I'm going to assume that you can see the calculator. And if not, I'm going to assume, a whole bunch of people are going to freak out and let me know that they can't see it. So the first thing I'm going to do is clear it. And then we're going to go second. This little second comes up here. And we're looking for the second function of the number 1 key, which says date. So second date. And DT1 pops up here and a bunch of other nonsense that you don't need. And we were looking at June. So we're going to go 6 for the month, decimal point, 30 for the day. And then we had to make up a year. So we made up 2021, but we can only put in the last 2 digits for 21. So we have 6.3021 and we go enter and we hit the down arrow. So now we're looking at DT2. Again, don't worry about what comes up here. It's just the last thing that ever happened to the calculator here. So we wanted October, which we decided was the 10th month, decimal point. The end of October is 31. Happy Halloween. And then we want still the year 21. And we go enter and we go down. And the number that pops up here, you have to remember that is not your answer. You have to tell the calculator, compute, and we get 123. Does anyone want to see that again? Okay. The next thing I'm going to do is I'm going to go to Excel and show you how to do it on Excel. So now I'm assuming you're looking at an Excel spreadsheet, and I'm going to enlarge it a bit so you can actually see what I'm typing in here. Maybe. Oh, can't enlarge it till I put something in there. So. So now you can read the words days between dates. We got the same answer by using simple calculator. What's a simple calculator? What is a simple calculator? And and the answer is yes. I'm not quite sure what a simple calculator is, but as long as you're getting the correct answer, you can use any calculator. They also teach you how to do it using something called a table of days, but I don't bother with that. But let's look at what we would do if we were doing this on Excel. Just type in the date, June 30th, 2021, right? Just type it in there. And then October, gotta spell it right. October 31st, 2021. And then all you have to do is go equals. So press equals, click on this date, and then subtract this date, and then go enter. And it'll tell you exactly how many days there were between those 2 dates. So Excel does an incredibly good job of dealing with dates. And yes, if you have any other calculator that will do that, it doesn't matter which calculator you do it on. You just have to make sure you end up with the right number of days. So now we're pretty sure we know how many days that is. Let's go back to our diagram here. Now our formula, because we're now trying to find the future value of 1,600 at 6.5% for 123 days. So our formula is going to look like this. S, which is the future value or the sum of the principal 1 plus R T. And we're going to plug in our numbers. 1,600, 1 plus the rate, 6.5%, times the time of 123, but we need to turn it into a decimal part of a year, 365. Make a mental note that this is never over 366. Even if you know you're dealing with a leap year, this fraction of a year is always over 365. When you solve this, you have to follow BEDMAS. In other words, you got to do the 123 divided by 365 times 6.5% plus 1. If you do the 1 plus 6.5, things will go horribly wrong. And I'm going to wait a few moments here, obviously not very long, and wait for a few people to come up with an answer. And as it's money, we know we're dealing with 2 decimal places. So I have one person who thinks they have an answer. Let's wait till we get a few more and see if we can all agree with one another. We do. We have several that are in agreement. So this is 1, 6. That didn't work. 1, 6, 3, 5, 0, 5. So we can see there's been $35.05 worth of interest. We could have calculated that separately and added it on. We could have done I equals PRT, which would have been 1,600 times 6.5% times 123 over 365. If we multiply this out, we now know we should get 3505. 123 divided by 365 times 6.5% times 1600. And indeed, we do get 35.05. And then we could have calculated S as being the principal plus the interest. But they don't want us to do it this way. They want us to do it all in one calculation using this formula. So now that we've done all this work, let's look at the questions they were actually asking us. What did they want to know? What was the due date of the note? We figured that out as October 31st. What is the amount of interest payable at the due date? The interest is the 35.05, and the maturity value, which is S, was the 1635.05. So any questions on that before we leap on to another one? Okay. So this one tells us a 120-day promissory note for $1,140 at 7.75%, dated February 19th, 2021. Now notice, instead of telling us months, they've told us days. And promissory notes will either be defined, the time period will either be defined in months or defined in days. Apparently they can be either way. So let's create this timeline and draw a little picture to try and depict what this is telling us. We know it's 120 days. So we can put that here. We also know that it was for 1,140. So that's the amount of money that was borrowed. That's referred to as the face value of the note, because that's the dollar figure written on the piece of paper. We also know, written on the piece of paper, is that the interest rate is 7.75%. And what they refer to as the date of issue is February 19. And they gave us the year of 2021. So now we have to figure out what date this thing is due. That's this date over here. So let's look at the BA2 plus. Let's again go second, date. We're now looking at DT1. And we know the first date is February. So that's the second month, decimal point. The day is 19 and the year is 2021. So we're going to go enter and down. Now the calculator has us looking at DT2, but we don't know DT2. So just hit the down arrow and go down to days between dates. And now we know the days between dates. So we're going to plug in 120 and we're going to go enter, but we don't go down. We're going to go up. And now we'll be looking at DT2 again. And we can now go compute. And the way the calculator works, as long as we put in any two and then go to the third one and compute it, it'll tell us that date. And someone suggesting that it's June 19th, 2021. So I haven't tried it yet. So if you're doing it, you can put the date in here and see what it is. Let me try it. Second date 2.1921, enter down, 120, enter up and compute. And indeed, I agree with you. I'm getting June 19th, 2021. June 19, 2021. Now, does anybody want to see me do that on the calculator?
Yes, sir, please.
Okay, let's go over to the calculator. Where did we lose it to? So we can see the calculator. I'll clear it. Sorry. So we go second, date. We can see what we did last time, but don't worry about it. We're now looking at February, which is the second month. So 2, then we need a decimal. And it was February 19th. So the day is 1/9 and the year is 2021, but we can only put in the 21. So we get 2.1921 and we go enter and down. We see DT2. We don't worry about what's in that register, but we don't know the second date. So we just hit the down arrow. We see DBD. We don't worry about the number that comes up because that's our previous calculation, but we know we're dealing with 120 days. We go enter, but we don't hit the down arrow. We want to hit the up arrow to go back up to DT2. And now we can tell the calculator to work with what's in the first and third registers and find the second register. And it's the 6th month, the 19th day of 2021. So that's what we already figured out, and that's how to do it on the calculator. Now, let me show you how to do that on Excel. So I'm assuming you can now see the Excel spreadsheet. I'll enlarge it again so we can all read it. And I'll stretch out this so I can get the date in there. And we were starting with February. So February 19, comma, 2021. But we don't know the second date. So what I'm going to have to put in here is I'll put the 120 in here. And now I can go equals this date plus 120 days and equals. And it comes up with 19 June 21, which is exactly the same answer we got before. So like I said, Excel is incredibly useful and functional when it comes to figuring out or dealing with dates. So now let's go back to our regular whiteboard. And so we now know the answer. What is the due date of this note? June 19, 2021. What is the amount of interest payable at the due date? So they're getting us to do this other calculation, which is really a waste of time, but I equals PRT. The principal we know is 1140. The rate is 7.75%. And we knew the time anyway, was 120 over 365. And so what do we get here? 120 divided by 365 times 7.75% times 1140. And I too am getting 2905. So now we could calculate S as principal plus interest, 1140 plus 29.05. So I'm getting 1169.05. So what is the amount of interest payable at the due date? That's the 29.05. But we should use the proper formula for calculating this. S equals P, times 1 plus RT. So 1140, 1 plus 7.75% times 120 over 365. Just to make absolutely sure we get the same answer doing both calculations. Let's try it. 120 divided by 365 times 7.75% equals now plus 1 times 1140. And indeed we get 1169.05. So 1169.05. So let's see what other strange stuff they can do to us. Any questions on what happened there? Good. I'll take that as a good sign that there's no questions. It could mean everybody's gone to sleep. So now they're going to switch it up a bit. They want us to determine the face value of a 4-month promissory note dated May 20th, 2022, with interest at 7.5% if the maturity value of the note is $1,190.03. So the face value is the original amount of money that was borrowed. And they call it the face value because that's the amount of money that is actually written on the face of the note. So let's look at our timeline here. What do we know? We know this is a 4-month note and it's dated May 20th. So we'll start at May 20th. They've given us a year. And we know we're going 4 months. 1, 2, 3, 4. And 20th is not the end of the month. So we're going to go May, June 20th, July 20th, August 20th, and September 20th. And we're still in the year 2022. So we now know this money was borrowed from May 20th to September 20th. We know it's borrowed at 7.5%, but we know in this case the maturity value, this is S. This is 1190.03. So the first thing we need to do is figure out the number of days. And I'm going to wait till a few people tell me how many days this is. And if everybody agrees with one another, that's the number of days we'll go with. So I get to sit back, have a cup of coffee, or at least a sip of my almost cold coffee. So I was going to say we had one guess, but now we have 2 guesses. And they don't agree with one another. So we need a few more people to come up with some numbers here. We seem to have some disagreement here over the number of days. Let's take a look at Excel here and see what we would get. What day did we start with? May 20th. 2022. So if we start with May 20th, is anybody looking at my Excel screen? I'm hoping May 20th.
Yes.
And we were looking at September 20th, 2022. If I go equals this minus this, and then enter, we're getting 123. So we're going to go with the 123 here. Let's go back to the whiteboard. So here we are back at the whiteboard, and we're going to be going with 123 days. And so now what they want us to do is use this formula. The principal equals the future value, or the sum, divided by 1 plus RT. And so we know the future value, 1190.03. 1 plus, the rate is 7.5%, times, and now we're going to deal with the 123 over 365. And if you calculate that, remember you have to follow BEDMAS. Try calculating that and let me know what answer you get. That's good. We all seem to be getting the same answer. 1106.69. Does anybody want to see me do that on the calculator? No? Okay, that's good. So that's all they wanted us to do there. Just find the maturity value. We had to find the number of days anyway, but they're just looking for the final answer, which is how much money must have been borrowed. That's a very weird amount of money to borrow, but that's what the numbers tell us. That's what we'll go with.
Sir, shouldn't it be 1160?
1160.
Yes.
11. Oh, I see. We got, what did I get on my calculator? I got 1160. Someone gave me 1106. Okay, thank you very much for pointing
You're
that out.
welcome. You're welcome.
So 1160. Yes. Okay. Okay. So let's see what else they can do to us here. So this is a very strangely worded question. And the wording only makes sense if you've done the sort of examples leading up to it. But I'll make I'll try to make it make sense. Calculate the present value of a non-interest bearing 7-month promissory note for $1,800 dated August 7th, 2021. And then it says on December 20th, 2021, if money is then worth 9%. So let's try and describe what has happened here. There's 3 people involved here. One person loaned an amount of money to another person, but they didn't charge them any interest. So, because it's non-interest bearing. So the amount of money that was borrowed, and that's the face value of the note, was $1,800. And when the other person has to pay it back, it's still $1,800 because they didn't charge them any interest. So it was dated August 7th. So that's the date of issue, August 7th, 2021. And so everything would have been fine if this person had just loaned this money to this person. And then at this point in time that we haven't figured out yet, this person paid the money back. Unfortunately, things didn't work out so well. This person decided that they needed their money or needed some money early. And what they did was they sold this piece of paper. Promissory notes are legally transferable financial instruments. One person can sell this piece of paper to someone else. And then the other person has the right to collect the amount that's due. And the amount that's due here is $1,800. But the person who bought this piece of paper, they weren't willing to lend the money for free. They wanted to get 9% on their investment. So on December 20th, so we've got to go back to December 20th, 2021. This person said, yes, I will buy that piece of paper that's worth $1,800 when it matures, but I'll only pay you the amount of money that will allow me to get 9% return on my investment. So what we have to do, the first thing we have to do is figure out what this date is. When is this piece of paper due? So you can either use the BA2 Plus, or you can use Excel, but one way or another, you've got to figure out what this date is. So I'll give people a few moments to see if they can find a way to do that. First off, let's deal with the 7 months. That'll help. We know we're going from August 7th, 1, 2, 3, 4, 5, 6, 7. So we know we're dealing with 7 months, and we're starting on a date that's in the middle of the month. So August 7th, August, September, October. Oh, I don't have December in the right place. September, October, November, December, January, February, March. So let's try and get rid of this because I got it in the wrong place. Okay. So let's August, September, October, November, December, January, February, March. So this has to be March. And it has to be March 7th. But now we're into the year 2022. So now that we know this is March 7th, we can figure out how many days this is. And I'm getting a couple of suggestions. And now I got 3 different suggestions. That's kind of scary. Let's go second date, August is the 8th month, 8.07. When you put the 7 in, it has to be 07 because there has to be 2 digits for the date. So 8/07/21. Let's write this down. Second date, DT1. August is the 8th month, so 8 dot, it's got to be 07/21. Then enter down. Then DT2, March is the 3rd month, 07/22. Enter down. And then we're looking at DBD. We go compute. And people are agreeing now that we're getting 2012 or 212. So 8, enter down, 3.0722, enter down, compute. And I too get 212 days. So we'll put that in here. 212 days. Now, we might not even need to ever use that 212 because the second part of the question says that we came back. Now we know where December 20th is here. It should be right here. December 20th, 2021. And so this person wants to get 9% return. So now what we're tasked with figuring out is how many days is it from December 20th to March 7th. We have a suggestion of 77 days. Anybody else getting the same? Couple of people agree on 77 days. Let's go with that. Days equals 77. So that, once we know the number of days, now we know this thing matures to 1,800. We know they want 9% on their money, and we know they're lending the money for 77 days. So we have to go back to this equation. we're looking for the principal. We know the future value. We know the rate. And we know the time. So 1,800, 1 plus the rate, they want 9%, times the time of 77 over 365. So this will tell us how much they were willing to pay for that piece of paper that they know matures to $1,800. We have one suggestion. I better check it, find out what my suggestion would be. One, 76646, that looks good. 1766.46. So that's the answer to the question. That's the present value of that piece of paper. That's what it's worth right here. 1766.46. So let's go over how strangely worded that question was. Calculate the present value of a non-interest bearing 7-month promissory note for $1,800 dated August 7th, 2021. And then it says on December 20th, 2021, if money is then worth 9%. So, like I said, there's 3 people involved here. One person loaned 1,800 to another person, and the other person agreed to pay it back on March the 7th, because we knew it was a 7-month note. But this person ran out of money and they needed some cash. So they sold this piece of paper on December 20th. They probably needed money to buy their wife a Christmas present. And so they sold this piece of paper to someone. But the third person involved here was not willing to lend the money interest-free. They said, I'll only buy this piece of paper if I get 9% return on my money. So then we had to figure out how many days were between December 20th and March 7th. And then we had to figure out what they were willing to pay for the piece of paper on the basis that they would get 9% return after 77 days. And like I say, it's a very strangely worded question, but of course it makes sense if you've done the examples in the textbook. It doesn't make sense sort of on its own. So let's see what else they can do to us. So compute the proceeds. The proceeds is the sale value. If you see them use the word proceeds, that's the sale value or the selling price. That's how much money someone got. So compute the proceeds of a 5-month, $7,000 promissory note dated September 6, 2022, with interest at 5.5%. If the note is paid on November 28th, 2022, when money is worth 6.5%. Okay, another very strangely worded question, but let's see if we can describe what they're talking about here. First off, we'll deal with the original piece of paper. It was dated September 6th. So we know we're starting at September 6th, 2022. And it's a 5-month note. So 1, 2, 3, 4, 5. So September, we're going to be going October, November, December, January, February, and we started on the 6th, so we're going to land on the 6th, but we were in 2022, so now we've moved into 2023. And we're going to probably have to figure out or want to know how many days that is, although maybe not, because we didn't use the 212 days last time. Maybe we don't need to know how many days this is. Oh no, I think we will, because this isn't a non-interest bearing note. So it's $7,000. And they had interest at 5.5%. So that's all the information on the original note. The first thing we're going to have to do is figure out what is this thing worth on the day that it matures. So we do need to know the number of days. And we're being suggested that this is 153 days. I need a few other people to calculate that to see if we can agree on that. Okay. 3 people is good enough. Let's go for 153 days. Once we know the number of days, we can calculate what this piece of paper is worth on the day that it matures. So we're going to be going S equals P 1 plus RT. We know the principal is 7,000. 1 plus, we know the rate because it was given to us, 5.5%. And we now think we know the number of days. So let's see if we can agree on what that piece of paper is worth on the maturity date. Well, we have 3 answers. They all agree with one another. I'm going to go with that answer unless somebody freaks out and says they just can't stand that answer. 7161.38. So that's what this piece of paper is worth when it matures. But on November 28th, when money is worth 6.5%, this piece of paper was obviously sold. So we've got to go back to November 28th, which I'll say is right here. And this is still in the year 2022. And this, at this point in time, money is worth 6.5%. And so what we need to know is how many days from November 28th to February 6th. And it looks like we're going to go for days equals 70. And once we know that, we know everything we need to figure out what that piece of paper would have been worth at this date at 6.5%. So we're now calculating the present value equals the future value, or the sum, over 1 plus RT. But the future value is the 7161.38. The rate is now 6.5%. And we're dealing with the 70 days. We got two answers. Strangely enough, two answers from the same person. Curiouser and curiouser. Yes, I'm going to go also with the 7073.21. So that's what this piece of paper would be worth on November 28th. So that's basically all they're going to get you to do with promissory notes. They're going to get you to take them forward and take them backwards. So now we're going to move on to something called treasury bills. Usually just referred to as T-bills. And this is a situation where a government has borrowed money So this is a government, either a provincial government, a state government, a national government, has borrowed money from an individual. And treasury bills are slightly different than promissory notes. One difference is the face value is the future value. So it becomes a bit confusing because when they refer to the face value of a promissory note, they're referring to the present value. When they refer to the face value of a T-bill, that's the future value, because that's the amount of money that is going to be paid back in the end. So we usually have to calculate the present value. Right, sort of the standard situation dealing with a T-bill is that you know the future value, and we have to figure out what someone would have paid for that piece of paper. What else do we need to know here? The interest rate, or it's referred to as they're sold at a discount. In other words, we have to always figure out the present value. And T-bills will always be specific number of days. They'll either be 91 days. They could be 30 days. They could be 182 days. Except once in a while, I think Quebec has 183-day notes, or 364 days. But they're always less than 1 year. Annoyingly enough, this 364 days is referred to as a 1-year note or a 1-year bill, which is annoying because it's not 1 year, it's 1 day less than a year. So let's take a look at calculating some of these T-bills. So what is the price of a 91-day, $25,000 Government of Canada Treasury bill that yields 1.28% per annum? The terminology that they use for T-bills is a bit weird. They don't refer to the interest rate. They refer to the yield on the bill. But the yield on the bill is the interest rate. So this 1.28% per annum per year is our interest rate. So let's draw a little picture here to describe what we know. We know this is a 91-day bill. We're not given any dates. We just know days equals 91. Because it's a $25,000 T-bill, we know that's the maturity value. $25,000. And we also know that they're getting 1.28% return on their investment. So the sort of the standard T-bill problem is find out what they would have paid for it. So we're looking for the present value. We know the future value. We know the rate. And we know the time. So 25,000 over 1 plus the rate is 1.28%, and 91 over 365. So what would somebody have paid for this piece of paper if they know that it matures to $25,000 after 91 days and they want to get 1.28% on their investment? We've got two answers and they're very close. They have to be exact, but close is good. 91 divided by 365 times 1.28% plus 1, then 1 over x times 25000, and I'm getting 24920.47. So that's the standard sort of T-bill scenario. And that's in the real world, that's what would be known. The face value of the note is the future value. The days is given, and we know the interest rate. What would somebody be willing to pay for that piece of paper? And now they try switching up everything they can to make life more difficult for us. So let's see what else they can do. So an investment dealer paid $24,756.25 to acquire a $25,000 182 Government of Canada Treasury bill at the weekly auction. So T-bills are sold at weekly auctions. The Treasury Department sells them by auction every week. And so this is what someone paid for it. And they know it matures to this. So in this case, what we're being asked to do is figure out what's the annual rate of return. In other words, what rate of interest are they getting on their money? We know it's 182 days. We know it's a $25,000 T-bill, but in this case, we know what they paid for it. They paid $24,756 25. And they're asking us to find the rate of return. That's the interest rate. So let's go back to what we know. We know the interest amount, which is the difference between these two, is equal to the principal times the rate times the time. And they're wanting us to find the rate. So we have to solve this for R. So the rate equals the interest amount divided by the principal times the time. And we'll have to go times 100 to turn it into a percentage, because this will give us a decimal. So first off, let's find the interest amount. Interest amount equals 25,000 minus 24,756.25. What does that equal to? How much interest did they actually get in terms of a dollar value? Well, we got three answers. They all agree with one another. So that looks like we'll go with that. $243.75. So now we can take this and put it into this equation here. R equals the interest amount, 243.75, divided by, now the principal amount invested is this ridiculous number here, 24,756.25. And the time is the 182 days. So we need a fraction of a year. So 182 over 365. And when we solve this, we'll get some kind of a weird decimal number, but we'll go times 100. And they haven't told us. So let's go to 4 decimal places. So when we get this answer times 100, what will it be to 4 decimal places? And we have one answer. We still only have one answer. I'm hoping for a few more answers so they all agree with one another. That's a weird answer. Let's go with that. If we're going to 4 decimal places, it's 1.9746%. So in that scenario, they gave us the future value and the present value and the number of days, and they expected us to find what rate of return they're actually getting. So let's see what other ridiculous things they can do to us. So an investor purchased a 182-day, $100,000 T-bill on its issue date, and it yielded 3.85%. So first off, let's deal with what we know about the original purchase here. We know it's 182 days. So and it's a $100,000 T-bill, but as it's a T-bill, we know this is the maturity value. And we know that it yielded 3.85%. So the interest rate was 3.85%. The first thing we want to do is figure out what they paid for it. So we're looking for the present value equals the 100,000 over 1 plus 3.85% times 182 over 365. So I'll just hold up here for a minute and let you calculate that. Okay, we all seem to be agreeing that this is 98116.43. So I'm going to hope that's a really good answer. So what was the original price of the T-bill? That's this. Let's put that in here. 98116.43. So when the T-bill was sold, what was its yield to maturity rate? So now we have to read the next sentence. The investor held the T-bill for 67 days and then sold it for this amount. So they held the T-bill from here to here, which was days equals 67. So what we need to know is how many days were left on the T-bill. So if you calculate the number of days left, how many days is it? Looks like 115 days. So now they want to know when the T-bill was sold, what was its yield to maturity rate? So we know how much they sold it for. They told us they sold it for 98853 84. So we now know what it matures to, what it was worth at this point in time, and the number of days left on the bill. So again, we're being asked to figure out the rate. So rate equals the interest amount divided by the principal times the time. So the first thing we need to figure out is how much interest did they actually get? So 100,000 minus 98853.84. And when I said we need to figure that out, I was actually meaning you would figure it out for me. Okay. 1146.16. So now we can calculate this. 1146.16 divided by the principal, which is this amount of money, 98853.84 times the 115 over 365. And you're going to have to go times 100 to turn it into a percentage. And again, let's go to 4 decimals here. And let's see if our guesses agree with one another. And we're getting 3.6800%. A few people are getting 3.6799. But if you look at the number next to the 9, it should round up. Because I'm getting 3.67990756. So this 9 should cause this thing to round up to 3.6800. So that should be the rate. 3.6800%. So That's what they're gonna get you to do with T-bills. Again, just like promissory notes. They're gonna get you to take them forward, take them backwards. And then they're often gonna get you to figure out the rate of return. Because that's the way it works with T-bills. People know what it matures to. They know what they paid for it because they bought it at an auction. And then the way they decided what they were willing to pay for it is by calculating the rate of return they would get. So you're going to often have to calculate the rate of return on the T-bill. And quite often it'll go to 3 or 4 decimal places. They want the answer to 3 or 4 decimal places. So now let's take a look at demand loans. So this is where an individual, a person, has borrowed money from a bank. Can we have a 10-minute break? Yes. Let's have a 10-minute break. What time is it now? 10:55. Let's come back at 11:10. So break until 10 minutes after 11. Does that work? Good idea. Ooh, rigor mortis has set in. We're on a 10-minute break. Shouldn't be a student. None of them should have my phone number. with Milagros. She's Peruvian. Heather. Milagros. Okay. I hope everybody enjoyed their break. And I guess more importantly, I hope everybody made it back. So we're talking about demand loans. And demand loans are a situation where a person or an individual, maybe a company, has borrowed money from a bank or any financial institute. And we have two situations here. Depending on whether the person has a bank account at the bank, the easiest situation is called the separate interest method. And the separate interest method is based on the idea that this person has a bank account at the bank, which is fairly normal. And we can separate, I guess, the interest payments from the principal payments. Hence, it's called the separate interest method. The second situation, which is called the declining balance method, is where this person does not have a bank account at this bank. And so we cannot separate the interest payments from the principal payments. So this one is a little more complicated. So let's do an example of the separate interest method first. And you'll see that it's fairly simple. So someone by the name of Jamie borrowed $900 from the Essex District Credit Union. The loan agreement provided for repayment of the loan in 4 equal monthly payments, plus interest at 12% per annum, calculated on the unpaid balance. The credit union will withdraw the interest payments from Jamie's account, and they tell us use the separate interest method. So the first thing we need to do, we know it's 4 payments, and we know he or she, I'm not quite sure what a Jamie is, borrowed $900. So figure out what the payments on the principal will be. 900 divided by 4, 900 divided by 4 are $225. So what they're gonna do. We don't know, we don't have any idea which months they are. So we're gonna calculate the first month's interest. They owe $900 times the interest rate of 12% times 1/12 of a year. So this is I equals P R T. So this is our I equals PRT calculation. And we can figure out how much interest they paid. So 1 divided by 12 times 12% times 900. They paid $9 interest. So the bank took $9 interest out of their account, and then they made a payment of $225 separately. And so we go 900 minus the 225. For the next month, they owe $675. And it's still at 12%. And that's how much money they owe for this month. So we can figure out how much money the bank will take. 1 divided by 12 times 12% times 6.75, 675. And amazingly enough, it works out to $6.75. So the bank takes the $6.75 out of Jamie's bank account, and a payment of $225 is made. So 675 minus 225. Now we're, oops, that didn't work. Now Jamie is down to owing $450, but they're paying 12% interest for 1/12 of the year. And amazingly enough, it'll work out to be $4.50. So a payment of $225 is made, and they're down to owing $225 at 12% interest for 1/12 of a year. And amazingly enough, it works out to being $2.25. Then another payment of $225 is made, and they're down to owing nothing. So we figured out how this whole process is going to work. What have they actually asked us? What was the loan balance outstanding after the second payment? So this was payment 1, payment 2. The loan balance was $450. How much total interest did Jamie pay on the loan? These are the amounts the bank took, but we have to sum them up. So let's try that. 9 plus 6.75 plus 4.5. Well, that didn't work at all. Try that again. 9 plus 6.75 plus 4.5 plus 2.25. They took $22.50. So $22.50. So that is an example of the separate interest method. And it's fairly simple because you can always separate the interest payments from the principal payments. So let's do an example of the declining balance method, unless there's any questions there. Does anybody have any questions about how that worked? Okay, I'll take that as a good sign. It could mean nobody's actually returned from the break yet, except one person, but let's hope that's not what it means. So So on April 2nd, Kelly borrowed 15,000 on a demand note with an interest rate of 9% per annum. Payments were made of 2,800 on May 14th and 2,400 on June 19th. And they want to know how much was the final payment, which was made on August 3rd. And they're telling us to use the declining balance method. So let's start here with Kelly. Again, we don't know whether Kelly is a male or a female or anything in between, but we don't really care. We do know that Kelly borrowed $15,000 on April 2nd. So let's start at April 2nd. And Kelly keeps this money, this $15,000, until May 14. On May 14th, Kelly comes into the bank and says to the bank teller, I'd like to pay $2,800 on my loan. So the first thing the bank teller has to do is figure out how many days are involved here. So now I'm hoping several of you will be the bank teller and figure out the number of days. Okay, that's a very good question. What year? And so you have to decide, are we worried about it being a leap year? So it's April. It's after February, and it goes to August. So it doesn't get into February. So it doesn't matter what year we use, because it won't, leap year, February 29th, won't interfere with us. So I'd say use this year, use 2021. Only if we're worried about leap year being a problem, do we suddenly really want to know what year it was. So we're being told that's 42 days. So now what the bank teller has to do is calculate the interest accrued on the loan. So the loan was for 15,000. So that's the principal times the rate, which was 9%, times the time, which we've decided is 42 days. But we're going to have to make that part of a year. So it's 42 over 365. So the bank teller finds out how much interest has accrued. That means how much interest is now owing on the loan. So this is our I equals PRT. I party. Sounds almost like fun. I party. Not so much fun when you realize how much math is entailed. So the bank teller has now determined that Kelly owes $155.34. So what the bank teller does is say to Kelly, okay, how much money do you have with you? Kelly coughs up 2,800. And now the bank teller takes off the interest that's owed to the bank straight off the top. So the bank teller now has to figure out how much money is left on Kelly's payment that can be applied to the loan. And this bank teller has multiple personalities, but luckily all of this teller's multiple personalities agreed on 2644.66. So now this amount of money can be taken off the principal. So the full amount of money that was borrowed was 15,000. And now they're going to take off 2,644.66 and see how much money Kelly still owes. One, 2, 3, 5, 5.34. So Kelly walks out of the bank. So basically the whole process starts over. Kelly walks out of the bank on May 14th and doesn't walk back into the bank until June 19th. And Kelly says, hi, I'd like to make a payment. So the bank teller looks back in his or her records, sees the last time Kelly was here was May 14th, and figures out the number of days. Uh-oh, the bank teller is confused now. One of the bank teller's personalities said 34. A few said 36. Let's go with the 36. So the amount of money that was owing on the loan was 1, 2, 3, 55.34. And that's accruing interest at 9% for 36 days, which we have to turn into a fraction of a year. So the bank teller, working with the 36 days, has to figure out how much interest has accrued on the loan. And so the bank teller determines that there's $109.67 owing to the bank. The bank teller asks Kelly, how much money do you have with you today? Kelly coughs up 2,400, and the bank teller immediately takes the 109.67 off of that. So how much is left that can be applied to the loan? And it turns out it's $2,290.33. So this is the amount that can be applied to the outstanding balance. And so the outstanding balance was 1235534. But now we can take off 2290.33 and figure out how much money Kelly still owes. And it looks like it's $1,065.01. And at this point, Kelly says thanks, or the bank says thanks. Someone should say thanks. And Kelly walks out of the bank. So when does Kelly show up again? Let's see, this is June 19th. Kelly doesn't show up again till August 3rd. Says, I'd like to make a payment. So the bank teller has to figure out how many days since Kelly's last payment. Looks like 45 days. So the bank teller looks at the amount of the loan that's outstanding. Knows that it's at 9% interest. And now needs to figure out what would 45 days interest be on that loan. And it looks like it's $111.68. The bank teller now asks Kelly, how much money do you want to pay today? And Kelly says, oh, I'd like to pay the whole thing off. Oh, no problem. the bank teller says, we'll take the original amount that you owed when you walked in here today, plus the interest. And if you pay us that amount today, that'll be the end of the story. And that's a weird number, because we want to add these two, not take them away. So 10176.69. So if Kelly makes this payment today, that'll be the end of the story. And that's the declining balance method. I'm glad they didn't make any more payments, or I'd have run out of room. So as you can see, the declining balance method is considerably more complicated than the simple interest method, just because of the nature of how it works. But this is the process. You always find out the interest accrued, subtract the interest from the payment, and then apply the payment to the principal to figure out how much is owed after that payment. And then the process happens again and again and again until the loan is paid off. So, any thoughts or concerns or questions about how that worked? Hopefully that's good. So they have something here called loan repayment schedules. And once this whole process gets more complicated, you're not going to want to do those calculations by hand. You're going to want to be doing them on Excel. So let's take a look at how that works. So on March 15th, someone by the name of Julio borrowed $900 from Sheridan Credit Union at 7.5% per annum, calculated on the daily balance. He gave the credit union 6 checks for $135, dated the 15th of each of the next 6 months, starting April 15th, and a check dated October 15th for the remaining balance to cover payment of interest and repayment of principal. And they want us to use the declining balance method. And they've given us the format to use in figure 8.7 and shown us how to use it in figure 8.9. So if you have a copy of the textbook available, let's find this. And then we'll go over to Excel and see what they're expecting us to do here. Figure 8.7. Okay. So if you're looking at it, they have the payment number, the balance before payment, the amount paid, the interest paid, the principal repaid, and the balance after payment. Basically the same calculations we just did by hand. They want us to do them in an Excel spreadsheet. So Let me just write down a few details that I need to know here. $900 we're starting with. 7.5%. Checks of 135. The 15th of each month, 6 months. Starting April 15, and then a final check on October 15th. So now let's go over and find an Excel spreadsheet and try to do this. Oops. So I'm hoping you're looking at an Excel spreadsheet on my screen here. If not, please let me know. So what do we know here? Let's start out by putting in the information they're giving us, or the framework they're giving us. They want us to have, oops,
I'm sorry, sir. Can you please zoom on it?
yes, I just have to type something in. For some reason, it wouldn't let me zoom until I got something to zoom on. So how's that?
Thank you. It's great. Thank you.
Okay, so let's put this into one cell. Balance. Balance before payment in that cell. And then I'll straighten these out so we can read them in a minute. Amount paid. And then interest paid. And then principal repaid. And then balance after payment. So let's stretch this over 3 cells. So merge and center, wrap text, and I'll center it. So that'll go there. And then I can use this thing up here called Format Painter. You can double click on it, and I can click each of these, and they'll do their best to follow the same format, and then hit escape to get out of that. So these are the 6 columns they gave us. So we can go over here to payment number, start at 0, and then go 1, 2, 3, and we can highlight that, grab this little handle here and drag it down. It'll go 4, 5, 6, 7, 8. I don't think we need 8, but that's okay. So I don't know why I left 2 spaces up here. Let's get rid of them. So the balance before the payment, how much did he borrow? He borrowed 900. So we can put that in here. And I'm going to highlight everything and center everything there. So now the amount paid is nothing. So for 0 here, I'm not sure we need anything happening at all. In fact, the balance before payment, I should probably put the 900 here, and we'll have nothing here. Oops. Nothing happening here. Oh, that still didn't work. Nothing. So we'll find out later if we needed that 0 row. Doesn't really look like we did. For payment number 1, he owed $900, but we know he paid $135. Now we need to do an interest calculation. So over here, although we don't have a column for it, let's have the rate of interest. They didn't tell us to put it there, but we got to put it somewhere. So the interest rate, what did they tell us, was 7.5%. So that's the rate of interest. And we know that we need to know the dates because they've given us actual dates. So we should use the actual number of days involved. So the date here was April 15. I don't think they gave us a year, so I'm going to use 2021. And we're going to go to May 15, 2021. So we need to know how many days that was, equals this minus this. So that's exactly 30 days. We could do it with 1/12 of a year, but as they gave us the actual days, I tend to think we should use the actual days. Now we know the number of days, we can figure out the interest paid because we know that there was $900 owed times 7.5% times 30 over 365. So that's telling us there was $5 interest charged on this loan. And if you do that calculation by hand, please let me know if that worked or not. But the problem is we can't go to 4 decimal places here because it's money. So the command for rounding it off, or the Excel rounding procedure, is ROUND bracket, and then at the end here go comma 2, and it'll round it to 2 decimals. So it turns out there's $5.55 interest. And if you check that on your own calculator, please let me know if somehow I've screwed that up. So now that we know there's interest being paid, and he paid $135, they're going to take the $555 straight off of the amount paid. So it's going to be equals the $135 payment, highlight that, minus the amount of interest that was owing. And so they're really taking off $129.45. And now, just like we did when we did it by hand, we can take this amount off the principal. So equals 900 minus the 129.45. So after this payment, who was it? Julio owes $770.55. Any questions on what happened there? Now, if you would like, once we finish this spreadsheet, I could email it to you. So you can actually see the commands and the calculations in each cell. So what happens next? The balance before the payment for the next month, we can put equals this, because we're starting again. And we know there's a payment of 135, but now we've got to work with the days again. This one, we can put equals May 15th. And now we have to add 1 month to that. So May 15th, June, June 15th, comma, 2021. And this calculation we did here, we can grab this little square at the end, which is the handle, and run it down. And notice now it's looking at these two dates and it's 31 days. So the interest paid, we can take this calculation, and we don't have to do the calculation again. We can just grab the handle and run it down. And nothing worked. Why not? Because we haven't filled in the interest rate. So let's go equals this. And the interest rate doesn't change. So let's just drag that down all the way now. So we won't be missing it every time. So now we see that they owed a little bit less money and they paid a little bit less interest. But we can drag this calculation down. That's the amount coming off the principal. And we drag this down and we see how much money they're owed. Once we've got this whole thing set up, we don't need to go payment by payment. We'll have to figure out the days, but let's figure out the days. Let's go. We can drag this one down. And notice it doesn't know what to do here yet. So we got to fill in the days. June 15th. July, August. And notice it fills in the next one as we go. August, September 15, 2021, May, June, July, August, September, October 15, 2021. And we don't really need to go past October, obviously, because he made the last payment on October 15th. So go over to this column and drag it down. And then highlight all of these and find the handle at the end here and drag this down. So we can obviously get rid of payment 7 and 8, so I'll just delete those. And this should be giving us the whole picture. We were asked to figure out, I think, what the final payment would have to be. Oh, we screwed it up here. See the 135? It started adding to his payment. So we got to change that. Equals 135. It's just this last one. We'll have to figure out how much it would be. Because they said he gave 1, 2, 3, 4, 5, 6 checks of 135. Let's go back and read the question. We might need payment number 7. So he gave 6 checks of 135. And then a check dated October 15th for the remaining balance. So let's figure out what happened. Let's go back to the other one. So we've given 1 May. So this check here was given on May. So 1, 2, 3, 4, 5, 6 checks of 135. And so on October 15th here, once he's given them the check for 135, he still owes $111.57. So if he's going to pay it off at this point, he'd have to give them a check for $111.57 to make that final payment. So, any questions that you can think of asking about how that whole process worked? Once you get more than a few payments for this declining balance method, it's way easier to figure it out on an Excel spreadsheet than to try doing it by hand. So as far as I can figure out, the final answer there would be the $111.57 that he's still owing. He'd have to write a check for that amount to finish off the loan. So, any questions that you can think of asking there? What you want to do is also watch the Chapter 7 video. And the set 13D will be anxiously waiting for this video to come out so they can watch it.
Sir, I would have a question.
Sure.
Can you show us, please, in which order did you drag and spread it, this spreadsheet? Um, that it got copied, or the functions?
Well, once we figured out the first two payments, right? We had,
Yes.
let's get rid of all this. Because we figured out the first payment, right? We started with, we know he owed 900. We knew he paid 135. Then we had to figure out the interest. So then when we realized we had to work with the interest, we came over here and we created a whole bunch of other work. We knew the interest rate was 7.5%. We knew he borrowed the money on April 15th. And so if he's going month by month, he's going to make a payment on May 15th. So we put those two in, we typed those dates in. And then we went equals this one minus this one to figure out the 30 days. Once we knew the 30 days and we knew the interest rate and we knew the principal, we could calculate the interest amount, which was 900 times 7.5% times the 30 days divided by 365. But when we plugged that in, it gave us a number to about 4 decimals. And so then we did round. And it won't enlarge the word round, but we have to do equals, round, put everything in a bracket with comma 2 to put it to 2 decimals. So once we knew the amount of interest, we could calculate the principal repaid by, first off, taking the amount of the payment and they take the interest off. So we did the 135, they took their payment, and we found there was 129 left. Then the next thing we did was take the balance minus the amount they paid, and that gave us the 770 that they're still left owing. So that was the result of the first payment, because they owed $900 for 1 month. So then we looked at the second month. So to find out where we were at the beginning of the second month, we just went equals and we highlighted this square here, or this cell. So we just moved it down here. We were told they paid 135, so we typed that in. But we had to calculate the amount of interest now on the $770 at 7.5% for what we determined was 31 days. So we got the amount of interest, and then we took the 135 minus the 491, and so there's $130 left. And so we could take that away from the amount, the outstanding balance of the loan, to find out now they only owe 640. Once we did that, we really had sort of our whole process set up. So we needed to copy the interest rate down. It doesn't change. So that was like, we did equals. Here it was a little more difficult because we had to plug in the 15th day of every month, right? So we actually typed in the days that they were making the payments. And here we just did this equals this. So as long as we had this column would just fall into place when we copied it down. And then once we had the dates and more specifically the days that we needed to know, I highlighted all of this.
Oh well, that's what I missed.
Yeah, just grab the whole row and I copied it down. It did all the calculations correctly, but it mistakenly thought that I wanted to be adding to 135. It made it 136, 137, 138, 139. So I had to change that. I went in here and I went equals this. And then I copied this down to keep the payment at 135. But it did all the other calculations for me. Right, does all these calculations because these calculations are in all these cells. So we determined that after the last check of 135, he's still owing $111.57. Now, if we'd done 1/12 of the year, it would be slightly different. So I'm not 100% sure whether they want us to go by the day or the month, but I think the bank would go by the day.
Thank you so much for explaining. Could you just please send this Excel sheet also for the 13D cohort?
Yes, I'll send it to both cohorts. I better save it. File, save as, this PC. Let's see. Zoom class. What's the date today? What is it?
13.
13th. October 13, and this is declining balance method. Not quite sure. Let's see. Okay, hopefully I'll be able to find that again. Okay. So, any other questions you can think of asking? I urge you very strongly to get used to doing these things on Excel. In the next chapters, we're going to be doing a whole bunch more stuff on Excel anyway. So certain aspects of Excel you'll definitely get used to. So can a loan repayment schedule be done with the separate interest method? Yes. Yes. We could. Yeah. Let's try it. Just for interest, if anybody's interested. Let's try it. Let's go back to Excel. Let's find another sheet. So you're now looking at an Excel spreadsheet. Separate interest method. Let's enlarge that. So let's first off, I'll go back here and I'll just steal these things that I typed in. And so we'll put the payments here, 0, 1, 2, 3, 4, 5, 6, 7, 8 that I don't think we need. I'll center it all so it works that way. Let's start again with the 900. We're doing the separate interest method. So in this case, if they're paying it off, if he wants to pay it off with 6 payments, we'd have to divide, we'd have to go equals 900 divided by 6. So it works out to be exactly 150. So we'll put the amount paid, he's going to pay 150. The interest paid, okay, we need to know our interest rate was 7.5%. Let's grab all the dates because we're going to need them all again anyway. And we've done all those calculations. In fact, let's grab this whole block. So I highlight it, I right click, copy, I come back here and I paste. And these things didn't fit very well. So I click on the whole column and I double click on the line in between them and it adjusts it. So click on the whole column, double click there. And so now we've got all that information. So now the interest paid, they're going to go into his bank account and get the interest. So it's going to be principal times the rate times the time of 30 divided by 365. Oops. And again, we get this weird decimal number. So I'm going to round it off. So RO round, comma, and then at the end, comma 2, or bracket, I should say. So again, it's 555. So the principal repaid, with the separate interest method, the principal is still the 155 or the 150 because they take the interest separately from the payment, right? And so the balance after the payment now, 900 minus the 150. Oh, I see. I had interest rate here. Should have been here. I'll put it there. And we'll get rid of that. So now he owes 750. So we go down here again, equals 750. He's paying 150, so equals 150. The interest paid, we can drag that down. So the interest is, the principal is 750. The interest rate is 7.5%, and it's for 31 days. So the interest paid is $4.78. But for the separate interest method, the principal repaid is his exact payment because he pays them separately. And so now we can drag this down. He's down to owing $600. And again, once we've seen how the first 2 lines work, we can just grab them all and run them down. And in this case, as I used equals here, it did the 150 correctly. And so these are the payments, 6 payments of 150. And what they're usually asking in the separate interest method is how much interest was paid. So go at the bottom of this column, go equals, and the command is sum, and then bracket, highlight these numbers, and end of bracket, and equals. So in this case, he'd have paid $19.73 interest, and he'd have paid it off with 6 exact payments of 150. So although I've never seen anybody do the separate interest method on a spreadsheet, for some reason I can't do anything with that. Let's figure out why not. There. Yeah. And that would be your final answer if they'd asked you to do it that way. But they never do. They expect you to do the separate interest method by hand, just because they figure it's so easy. So any other questions you can think of asking at that point? Really, all you have to do, unfortunately, is do as many questions as you can out of the textbook for homework until you feel you have a grip on it and it all makes sense. It's one of those situations where the more practice you do, the easier it gets. Okay. In that case, I've wasted 3 hours and 18 minutes of your life. I'll say goodbye. And next week, we'll leap into compound interest. Have a nice week.
Thank you, sir.
Thank you, sir.
Bye.
Okay, bye now.
Thank you.
And I'll post the recording as soon as they send it to me. But the other recording is there.